I'm Steve Satterfield. Welcome to the presentation of the process and the algorithm that extracts the knowledge areas, courses, and stated learning outcomes from the Leisure Learning course catalog here at UWF. I've documented the entire backend Python package and posted it on my GitHub page for review. And here is the documentation. Just a quick overview. I've emailed all of you the URL to this page already, so if you don't have it and you're interested in reviewing the code, please let me know. I spent quite a bit of time documenting this code with Sphinx so that it should be easy to follow. Note that in addition to the method signatures and descriptions of the methods and modules, you have links to the source code. You can actually view the source code. Now, I've tested this algorithm by parsing the fall 2019 catalog and the spring 2020 catalog. This morning I'm going to parse the fall 2019 catalog again as a demonstration so you can see this in action. So let's take a look at that catalog. Now this is the course catalog we're going to be parsing. This is the PDF version, by the way. I've converted this to a Word document, and it is the Word document version of this that the algorithm is going to be parsing, and that is right here. Now, just note the organization of the catalog. We have the knowledge areas and the course titles under each knowledge area, and further down in the document we have the descriptions of each course. And that is what the algorithm is going to extract, just those three things: the knowledge areas, the courses under the knowledge areas, and the description of each course. Then it is going to examine each sentence in each course description and select those it identifies as possible stated learning outcomes. Now let's take a quick look at the database. This is a Firebase database. Notice it's scholasticity.org test. Now at some point, as soon as I get the fall catalog parsed, I'll throw the switch and put this and run this again and put it over into the live database so that it'll get picked up by the front-end application that you've all seen. So I just want to demonstrate that I've cleared out all of the data, and so that at the end of the process that extracts the data and identifies the possible learning outcomes, a process that'll take about 90 seconds. We will look again at the database and you'll see that the data will have been added by that process. So here we are, just nothing except a user table with one test record in it. Okay, now let's see the algorithm in action. Let me close this. Now this is the algorithm, and you can see this in the documentation on my GitHub page. Parse catalog into database. So let's run this. Let me clear the console. The algorithm will go through a Microsoft Word document version of this catalog, as I said, and it will extract the knowledge areas such as arts and literature, the courses under each knowledge area, and the course descriptions. Then the algorithm is reading each sentence in each course description. It is tagging the parts of speech so that it can compare the verbs to a set of action verbs from the Bloom taxonomy. Each sentence containing such a verb is selected as a possible stated learning outcome. The algorithm will then place all of these elements into a cloud relational database that we've just seen, the Google Firebase real-time database. Note the console output showing the various major operations. I put this in just to help us pass the time as we watch this in real time. 90 seconds is a brief time for a process that parses an entire course catalog, but it's a long time for dead air. So I wanted to put something there so you could see what's going on. So now it's doing the extract courses and descriptions from the current document. That, of course, is the, as they say, the long pole in the tent. And now it's writing the extracted learning objectives to the database. And we'll be finished soon. Well, you can watch me enjoy my tea. And it's finished. Okay, I stand corrected. I tested it this morning before that, and it took 87 seconds. It took 135 seconds this time. But still, in the scheme of things, for what it's doing, that's not too bad. So let's take a look again at the database. And now, as you see, we have data. We have a catalog record, and I didn't mention this. It just puts in the name of the catalog, the semester and the year, and this is just for future use. So we won't always have to start out with a clean slate. Now the catalog record and the knowledge area records, the algorithm is written so that if before it adds a knowledge area, it will look in the database, because these knowledge areas, it's been my observation that they are pretty consistent. You know, I looked at the previous year's academic catalog before I started working on this, and then of course I've parsed fall 2019 and spring 2020 catalogs, and I've been told that the fall 2020 catalog will be structured in the same manner. So we'll have the knowledge areas and the courses under the knowledge areas. But these knowledge areas have been pretty consistent, and so there's no point having to clear those out and rewrite them every time. So what it's going to do is find the existing knowledge areas, if they're there already, grab this identifier and use that as the foreign keys in the courses that it adds. And if, of course, there is a new knowledge area, it's going to put that in. Now the knowledge area, note that it doesn't have any foreign keys in it because, as I said, these are pretty consistent throughout. However, the course has a foreign key back to the catalog and back to the knowledge area. So this is what tells us, okay, this course was extracted from the fall 2019 catalog. This tells us that this course belongs under, for example, arts and literature. Now, for those of you not in the computer science department, the foreign key is simply the identifier for the parent record. So this foreign key knowledge area ID, if you look at this is M9XQ, M9XQY. So it's just pointing to this record in the other table. So it's the primary key in this table. It's the foreign key in this course table, in the child table. Similarly, with the learning outcomes, learning objectives, they each have a foreign key back to the course. So that tells us when someone selects this learning objective in the front-end application, this is all we need to know which course to recommend based on that selection. That's a very simple process. Now these data are just raw captures of sentences from the catalog. You know, we examine the sentences if they contain a Bloom action word. The algorithm selects it as a possible stated learning outcome for that course, puts it in the database in this table, and then here we are. So for this version, I will be reviewing these manually and possibly tweaking some of the statements because some of these, they sort of relate to what you could learn, but it's not the best statement, not the best possible statement in some cases of what you could learn. So what I've done is I've written an algorithm just to enable this manual process where I'm going to review all of these stated learning outcomes that were extracted. And let's take a look at that. We have this module here, send extracted catalog to CSV. So what this is going to do is all of the data that we've just extracted from the catalog and put into the database, it's going to read the database and put all of that into an Excel workbook with a tab for each knowledge area. So let's run that very quickly and see how that works. And notice that ran pretty instantaneously. So now if we go and look at our Explorer, File Explorer, we're going to see in the Outputs folder, and it is 11:08 a.m. that this was just produced. So let's take a look at that. This is every knowledge area, course, and learning outcome from the database. Oh, here it is. Now let me just take a minute to fix these column widths. Now notice that I have the primary key, these IDs, in the records. That should be enough. Because what's going to happen is once I make modifications in this column here, learning objective as revised, then I'm going to run a third algorithm that's going to read my modifications from this workbook and update the database. Because I don't have any sort of a user interface on this back-end process. So this was the quick way to get myself a sort of a user interface that's better than just going through the raw data in the database. So let's start with this Irving Berlin course, and it picked up a sentence that says he could not read or write music. He could only play the piano in the key of F sharp major. Well, that's not really a great. You might not pick up on that as something you'd be interested in, and besides, it doesn't even say who it is talking about. So let's change this up to say learn about Irving Berlin's ability to compose, although he could not read or write music. Okay, so that changes up the Irving Berlin course. Now let's take a look at this Bach and Beyond, Intriguing World of 18th Century Harpsichord Music. It says Dr. Solanke is a friend of leisure learning, etc. Let's change that up a bit to say learn about harpsichord music from Dr. Eddie Solanke Rubart. A Juilliard School of Music graduate and one of today's foremost harpsichord performers. Next, let's take a look at this course, Calling All Bookies. This one it picked up just says, please read the book in preparation for the class. It picked up on the verb read. So let's just remove that. It's a good suggestion, but it's not really a learning outcome. And then it says our group grows each semester, but everyone gets a chance to talk. And the discussion, so it picked up on discussion probably. So let's, it's not a verb, but I've expanded it a little bit to more than just verbs. Because it's tagging all the parts of speech. I was able to work with any part of speech. So let's change that up to say learn about discuss the book Where the Crawdads Sing by Delia Owens. Now behind the scenes I've of course looked back into the course description and pick that out. And that's what I'll be doing in this process. Now, this process, once I get to this point, you've seen so far it took 135 seconds to extract all this information, and then I can instantaneously produce this workbook. So then it'll take me about an hour to manually go through all of these. Now, I'm not going to do that in front of you here, so I'm just going to demonstrate a couple of these. Now, we go down here, and this is what happens if it didn't pick up anything for a course. Then I've got the algorithm that produces this workbook written so that it'll give us a couple of blank rows with the course ID, so that when we put in a learning or unstated learning objective from what we know is in the course description, it will pick that up. So let's add a couple here. Let's say discuss how W.A. Mozart transformed opera. And then let's say here, baritone Corey McKern sing an aria from an example of one of Mozart's operas. So there we have a couple of potential things you could experience and or learn from this course. So that's all I'm going to do here. Now let's save this into the inputs folder. And change the name from review to reviewed so that the algorithm knows to pick this up. The next algorithm we're going to run. And here it is in the inputs folder. So now I'm going to go over here to a third algorithm that says update database from Excel review. Let's run that. Again, it ran very quickly. It's finished. So if we go back and look at the database, and here's our change. Learn about Irving Berlin's ability to compose, although he could not read or write music. That's what we said we wanted in the spreadsheet. Discuss the book Where the Crawdads Sing by Delia Owens. I have a typo in there, but this is just a demo. And also, you may have noted before that we saw the one for the same course, calling all bookies, that said read the book before coming to class. That is now gone because we put remove in place. And so, as you can see, the algorithm worked. Now, at this point in the actual process of processing of the Fall 2020 catalog, I would have revised all the necessary learning objectives and updated the database. And at that point, I would run the second algorithm again, produce a fresh Excel workbook with everything from the database in it. And if Ms. Robinson is interested in doing this, I would be happy to send her the Excel workbook at that time, just for a final review. But I just want to emphasize that this is not an attempt to ask the director to accomplish any of the necessary work for this process, but rather just a courtesy invitation to have a chance to review what the participants in an experiment involving a program will be looking at. So I just I want to make sure that's clear, that I'm not trying to task anyone else but myself with doing this work. So that's it. That's the algorithm, nicely documented for your review. And now we've seen it in action. Now, one of the objectives of my dissertation project is to demonstrate that such an algorithm could be written to extract the stated learning outcomes from the course descriptions and the course catalog. And if this were a purely computer science degree program, I would have added the capability to the algorithm to refine those learning outcome statements rather than having to do this manual process with the Excel output. But when I finish this work, I'd love to pursue that. But it's beyond the scope of a dissertation that is focused on the implications for education rather than the technology. I've written the algorithm that extracts the data from the course catalog in a very modular way so that it can be adapted to other course catalogs, formats in other programs or at other institutions by making very specific modifications in very specific places within the code. However, in the interest of finishing this project on time, I haven't attempted any such adaptation myself, and I would argue that that's beyond the scope of this project. However, a code review by the committee of the documentation that I've provided should be sufficient to establish that I designed the algorithm for adaptability. And adapting this code to another catalog in another program would be a very good follow-up study for somebody. Thank you, and please let me know your thoughts.